Let us find the derivative of log of sin x using definition of derivatives. We want the derivative of log of sin x using definition of derivative. For a function f(x), f dash x by definition is given by f dash x equal to limit x tends to 0 f of x plus h minus f of x divided by h. In this case, we have f(x) equal to log of sin x. So by definition, f dash x is given by limit x tends to 0 log of sin of x plus h minus log of sin x whole thing divided by h. Once again, f dash x equal to limit x tends to 0 log of sin of x plus h minus log of sin x divided by h. Let's read it as a and let's read this as b. We know that log of a minus log of b equal to log of a by b. Let's apply that relation here. So we have this limit h tends to 0. This stands as a and this stands as b, and log of a minus log of b equal to log of a by b. Log of sin of x plus h divided by sin x. Whole thing divided by h. Now, we know very few results about limits and logarithm. One of them is limit u tends to 0 log of 1 plus u whole thing divided by u equal to 1. Do we have such a result there? Not exactly, but we can get similar result there. How can we get? Well, if I add 1 here, then I should subtract 1 here. Equality still remains valid. And if we read this as u, then maybe we have some result. Let u equal to sin of x plus h divided by sin x minus 1. Then as h tends to 0, u tends to 0. Well and good. So we can write the above limit h, limit u tends to 0. We want to replace this quantity as u. Well and good, let's do it. So we have the limit equal to limit u tends to 0 log of, if we regard this as u, then we have log of 1 plus u, log of 1 plus u whole thing divided by h. But still we can't apply that formula. If we want to apply that formula which you know about logarithm, let's divide and multiply by u. Now we know that limit u tends to 0 log of 1 plus u by u equal to 1. The whole thing is just 1. But what about the other limit? This is just equal to 1 into limit u tends to 0 u by h. But as u tends to 0, h is tending to 0. So this is limit h tends to 0 u by h. Let's recall what was u. U is sin x plus h minus 1 by sin x. So sin x plus x by sin x minus 1. Let's replace the value of u. So we have limit h tends to 0. The value of u is sin x plus h divided by sin x minus 1. We have just replaced u as this quantity, which we have assumed it to be earlier. Now let's take the LCM of this quantity, or rather we simplify whole expression, and we have limit h tends to 0 sin x plus h minus sin x whole thing divided by sin x into h. Now sin x does not depend on h, so I can take sin x out of the limit 1 by sin x. That do not change as the h changes. Limit h tends to 0 sin x plus h minus sin x divided by h. Now this can be written as 1 by sin x. Instead of writing that, we know the result about sin c minus sin d. Sin c minus sin d equal to 2 cos c plus d by 2 into sin c minus d by 2. Let's apply that result. Sin c minus sin d equal to 2 cos c plus d by 2 into sin c minus d by 2. 1 by sin x as it is. Sin c minus sin d equal to 2 cos c plus d by 2. So x plus h plus x by 2 into sin c minus d by 2. X plus h minus x by 2. Everything to be divided by h. We forgot that limit h tends to 0. Limit h tends to 0. we can do a little bit of simplification. 2 we can take out of the limit and write it as limit h tends to 0 cos x plus h by 2 into sin h by 2. Whole thing divided by h. Now if h tends to 0, h by 2 will also tend to 0. So we can divide by 2 throughout. And observe that if h tends to 0, h by 2 is also tending to 0. So h by 2 is also tending to 0. And so this quantity is 1. If h tends to 0, h by 2 is tending to 0. So this quantity must be 1 in the limiting case. So we are just left out with 1 by sin x into cos x plus h by 2. If h tends to 0, that is just cos x. And that can be just written as cot x. So we have shown using first principle of derivative, or by definition of derivative, that derivative of log of sin x is cot x.